video, I'm going to give a demo on policy enforcement based on multiple policies, and we're going to test them in the ticket reservation scenario. I provisioned the ticket reservation scenario, and then let's start some initial trust parameters. Then we need to select policy trust configuration. The service trust means in the policy evaluation we need to have a value for trust that is going to be used for evaluation against the policy. Here we say that, for example, for TR1 we are interested to 0.8, not to the whole composition or session trust. Then we enable this configuration. After enabling these parameters, this will be updated on the TM service. Also, here we set the enforcement mode of the PME framework, and system right now is initialized and ready to enforce policies. Now let's take a quick look at the different policies that we have defined. These are 9 different policies that we have experimented with for this dissertation. I will explain 8 of them here in this demo, and the redirect, the trust redirect will be demonstrated in a separate video. Basically, these policies, ZACMA policies, work based on subject, resource, and action. It says whenever there is an access from a web service with the address which is expressed as a regular expression, and it's going to access one of the resources on the same machine, and the action is invocation, then we want to apply and enforce these policies, and then send back these effects that is going to be enforced by the PME components at the service level. Of course, I mean, in the cloud setting, all these subject and resources need to change, and the actual IP address of that machine should be replaced by the local host. But for this demo, the services are loaded on the same machine on my laptop. So we just provide local host here, which means a local IP address. Now let's start from the beginning, and let's try the trust policy. The trust policy defines one environment parameter, environment attribute, which is called a trust attribute. This is a new trust attribute that we have defined, and it says whenever a service is going to be invoked that has a trust value less than threshold, then prevent that service from happening. Let's come back to the demo, and here let's search for a ticket from Seattle to Indianapolis first. These are the available tickets, and now we want to upload the trust policy. This is the policy that we are looking for. Here we can see that this trust parameter has been set, that whenever this value is less than threshold 0.5, then we want to deny that request. After uploading the policy into the policy engine, then we will publish it to PDP and enable it in the PDP. Now policy is ready to be served to the PME requests. Here, for example, we want to query one of the requests by a trust value less than 5. For this, to test that one, we reduce the trust value of DL1 to 0.3, and then we will try to confirm one of the tickets from Delta. Based on this policy, since TR1 is going to call DL1, and DL1 and the trust value of DL1 is less than threshold, then this invocation should be prevented, and we shouldn't see the message of confirmation. And as we can see, this ticket is not confirmed here because of the trust value. We want to see what happens if we disable this policy here. If we disable and try again the confirmation, we see that this time it was the payment is confirmed and the ticket was confirmed since the policy is disabled on the server. This is for the trust, which is the simplest policy. Now we delete that policy on the server, and we go back to the second policy. The list of second policy is a trust pause. Basically, the trust pause has the same logic, which means if the trust value of the target service is less than threshold, then instead of denying and preventing that invocation, we just pause for 5 seconds, and then we allow that request to be processed. What's the purpose of this policy? This policy can be very useful for scenarios that we want to control the rate of input request, and we want to throttle the request. For example, we want to limit the number of requests per hour for that can access to a service. Then we can use a trust policy or a policy similar to this logic here. Now let's come back to the demo and select the pause policy, and we publish and enable the PDP. Based on this policy, let's try this time by changing the trust value of DL1. We turn it back to a trust 4C, and let's try to change the trust value of UN this time. For the UN, we can change the trust value to 41, and this time we try to reserve this ticket from United, which is going to be the path of invocation is going to be TR1 to UN1 to BN1. After, by the way, the trust update shows the invocations so far that has been happening here. After confirming and calling the confirmation of this ticket, we see that it pauses here for 5 seconds, and then it will succeed. And then after it succeeds, we have this ticket. We continue the demo by working and experimenting with new trust. Let's delete this trust and come back to the list of trust again. We experimented the trust and trust pause. We skipped the trust redirect. It will be on another video. Let's take a look at the blacklist and whitelist. Basically, with using these two policies, we can blacklist certain services or whitelist certain services. In the blacklist, for example, we say whenever we want to call an American Airlines service, that call must be denied. Let's try that one here. We come back here and search again. These are, we have one ticket from American Airlines. After uploading the blacklist policy to the WSO2 policy engine, we will test whether we can confirm this ticket or not. We see that we cannot confirm here as this service is blocked, the American Airlines. What about trying with the Delta? If we want to confirm this Delta ticket, since it's not blacklisted, we should be able to successfully confirm that ticket. Let me see, it's been successful. We come back to the list of policies. The next policy is whitelist. Whitelist says whenever we want any access to services that is not American or United or banking, then it should be denied. On the other hand, in our scenario, it means whenever we want to access to a Delta service, it should be denied. Otherwise, for other services, it will be allowed. That service will be allowed. We come back here and load the policy. To write this policy, we publish it on the server. And here we see that we have another Delta here. Let's search again to remove the previous one. I disable this policy on the server to be able to search here again. I search here and we have just one Delta left here. Now I enable the policy again, and this time I should be able to confirm this ticket here. Let's try and see what happens. As we see, there is no confirmation. We cannot confirm that ticket based on this policy. Delete this again, and let's see the next policy. The next policy is airline trust. It means whenever we want to access a certain airline that has a trust value less than 5, then we want to deny that request. Here that airline is American Airline. So if access is going to be for American Airline and the trust value is less than 5, we deny it. Otherwise, we will allow that request. So it's getting more complex, and here we have two different conditions that will be evaluated by the policy engine. Airline and trust. We publish this on the server, and you see we have one American Airline left. At the moment, if I want to confirm, it will be confirmed since the trust value of American Airline is 0.85. But I try to reduce that trust like to 0.2, and now we try to confirm this ticket. As you can see, this ticket is prevented from confirmation. We can also try some other for some other dates. For example, if we search here, let's disable this first on the PDP and search again for other date. We have another ticket here that we want to show if we increase the trust value of American Airline. With this policy, we will be able to confirm that ticket. We enable that trust back again. That previous operation was for search. Now we want to confirm this ticket. So let's and we tried that with trust value 0.2. It was blocked. Now we increase it trust value 0.2 to for example 0.8. And we try the confirmation, and we see that this ticket will be confirmed. The next policy is price, which says whenever the price of an airfare is greater than 600, then deny the confirmation. So this is more semantic type of policies that we for applying this policy, we extract the price value from the request that is sent to the ticket reservation, and we send that request to TM service, and TM service extracts this price value and creates a ZACML request, sends to policy engine, and policy engine works based on this price environment that we have defined here. So let's try this policy and see how it works. We approve the price here, enable that on the server, and this time if we want to confirm the American Airline ticket, let's try with come back to the previous one and test on the United. If we search here, we have a United Airline here, one ticket which is over 750. For the confirmation, we try to confirm this ticket, and as we see, it's blocked, this confirmation from the United. But if we remove this policy, then we will be able to confirm this ticket too. The next policy is the price and trust. It means if the price is greater than 600 and the trust value is less than 0.5, then it should be blocked, the request. Price and trust. For the price and trust, this time the trust value is 0.41 and the price is 750. Then, as we see in the policy, it should be prevented since the trust value, both of the conditions are met here. As we see, it's blocked, this service. And the last policy is also interesting. That's for price, trust, and date. It means if the trust value is less than 0.5 and if the price is over 600 and if the date is 11th or 12th, then we will block. Otherwise, we should allow this policy. Let's try here. For example, trust is lower than threshold and price is 750, but the date is 10th, it's not 11th or 12th. Then we should be able to confirm this ticket successfully, as we can see. Now let's search for tickets on 11th here. Unfortunately, we don't have any ticket over 750. I will try to redeploy it again and demonstrate this policy with another ticket on the 11th. I just reprovisioned the scenario to be able to show the effect of the last policy. Let's try again by querying the tickets available on the 11th. These are the list of available tickets, and we have one ticket with the price over 600 and on 11th, but it's from American Airlines. If we try to confirm this one, it will be successful this time because the trust value of American Airlines is greater than threshold. Let's reduce the trust value to less than a threshold, and let's upload our policy again. The price, trust, and date policy. And we publish and enable this policy on the policy engine. This time, since the trust is less than threshold, price is greater than the specified threshold, and the date is also is a block date, then we should not be able to confirm this ticket. And as we can see, this is not successful. But if we change any of these things, for example, if we change the trust value, that here we have the option to change the trust to, for example, 0.56, which is greater than threshold, then we should be able to confirm the ticket, and as we can see here. And these are the the 9 different policies that we have here, and all of them can be combined with each other. We have a lot of flexibilities to extract the context using the PME framework. We can extract the different type of context. We can get the trust values from TM service, and by combining them, we can come up with many more different type of policies. But these 9 policies are just representative policies that show the ability to enforce user-defined policies.